you may have seen some effects. Some of these effects may be like bending of a pen once you dip it in a glass of water. If you observe it from outside, you can see that pen is bending. That bending effect is brought about because of as light travels from one medium to the other, it tends to change speed. When light is moving from air to water, for example, it tends to slow down, meaning it is faster in air, but the moment it gets inside the water, it tends to slow down. That slowing down is what causes light to bend, and this effect is known as refraction of light. There's some of the objectives that will be important to us to learn, and these objectives are: the first thing, you should be able to indicate the normal, the angle of incidence, and the angle of refraction. That is very important. Okay. The second one should be you should be able to define the state and the formula for the refractive index. Once, if you are supposed to define what refractive index is, you should simply be able to give it using the equation of the ratios of sine of angle of incidence to the sine of angle of refraction. Finally, you should be able to use this equation to solve problem, meaning if you're required to make one quantity the subject of the formula so that you can find the missing quantity or the quantity in question, you should be able to do that one as well. Well, let's get to the introduction. Now, as we said, the definition of that is a refraction. It is the bending of light as it travels between mediums of different densities, e.g. from air to water. The diagram below, we can see that there is an incident ray that is in one medium, and it travels and hits the boundary between the two mediums at an angle I. This angle I between the normal, which is usually perpendicular to the surface, and the ray itself is known as the angle of incidence. It's what we are calling here the angle of incidence. Now, once the light enters the more dense mediums, it tends to bend towards the normal. Now, the angle between the normal and the refracted ray, as you can see it here, denoted by R, is known as the angle of refraction. Okay. Now, when light travels from a less dense medium to a more dense medium, it slows down, and this will cause it to bend. In other words, there is change in velocity from a high velocity to a low velocity, as can be shown on the diagram below. The other noticeable change is the change in wavelength. The wavelength of light once in a more dense medium tends to be compressed together. In other words, they tend to decrease, as shown in our diagram below. Now, the refractive index. The refractive index of a material is a measure of change in the speed of light as it passes from a vacuum or air, as an approximation, into the material. Mathematically speaking, we can define it as the ratio of sine of the angle of incidence to the sine of the angle of refraction. We use the symbol n for refractive index here, and basically it will be used in very many other examples. We say refractive index n is equals to sin I over sin r. Now let's have an example. The angle of incidence of light moving from air to glass is measured to be 27 degrees. If the measured angle of refraction is 18 degrees, what is the refractive index of the glass? Now, in the solution, the first important things to do, which are the basics, would be to write down or to note down the given quantities in the example. One is the angle of incidence is given as 27 degrees, and the angle of refraction is being given as 18 degrees. Now, to get the refractive index, that is from our formula, we say it's sin I over sin R. That is sine of angle of incidence over sine of the angle of refraction. Now, the sine of 27, if you check from your calculator, is 0.45, and the sine of 18 from your calculator is 0.31. When we divide the two ratio, we get 1.47. Point to note: refractive index have no units. This is because it's a ratio of two angles, and therefore a ratio will not have units. Another example, in this particular example this time round, we would want to make one quantity the subject of the formula, and then use the given quantities to solve the missing quantity. The example is as follows: the refractive index of a material is 1.50. If a ray of light from air is incident on this material at an angle of 30 degrees, what will be the angle of diffraction? Now, again, basically, we note down the given quantities. We have the refractive index N is equals to 1.50, and we have the angle of incidence I is equals to 30 degrees. Now, from our formula, N refractive index is equals to sin I over sin R. Then we make R the subject of the formula. It would be sin R is equals to sin I over N, N being the subject, that N being the refractive index of our material. Now, sin R is equals to sin 30, meaning we're just substituting the given quantities. Sin 30 over 1.50. The answer will be 0.33. Therefore, if we find what we call the that is the sine inverse of 0.33, we get 19.5 degrees. That is 2 3 significant figures, and therefore our answer that we were supposed to give here for the angle of diffraction is 19.5 degrees. Okay, how do we identify the angle of incidence in a practical example? One thing we need to realize is that, first of all, the angle of incidence is formed between the normal and the incident ray. Here we have our laser torch. So if we switch on the laser torch, we can see the angle here, and our protractor is here. You place the protractor, that is 0 being on the normal, and then we move across, and we can see this is 25, 26, 27, 28. Is approximately 28 degrees in this example. Okay, now from the other side, that is in a material whose refractive index is 1.47, you can see that the ray is bent toward the normal, and the angle of refraction, this one, we can see is that is from 0 all the way. This is 10, 15, 16, 17, approximately 17 degrees is our angle of diffraction. Okay, that's it.